Our next lesson starts on page 6 in our notes packet, and it's lesson 10.3. We're going to talk about some measures of variability, starting with box and whisker plots today. So a box and whisker plot summarizes a set of data along a number line. So every time we see one of these, we're going to see it along a number line here. It divides a set of data into 4 parts, which we're going to call quartiles, which each represent 25% of your data. So basically what you're going to do is you're going to take your data set, you're going to order them from least to greatest. You're going to find your median. This number, if it's an actual number itself, is going to now be excluded from the 2 new sets of data. So finding the median will essentially break your data in 2. So if this is your data set down here, that median is going to be this middle number. If it is actually a number that's in your data set, it's now a special number. It's going to disappear, and it has essentially broken up your data into this upper half and this lower half. If your median is actually found by finding the average of 2 numbers in the middle, you will actually create a new number that will become part of your data set as the median, and then those numbers that you used will actually still be included in that bottom and that upper set then. In the lower half of the data set, again, you're going to find your median, which will be in the middle. You'll do the same thing in the upper half of the data set. Those are called your lower and upper quartiles. So that's step number 3 up here. The last thing that you do is to find your lower extreme and your upper extreme. So you'll notice we have a total of 5 points here. Largest and smallest numbers are those extremes, by the way. You're going to plot those 5 points for 5 values above a number line. You form a box connecting the middle 3 numbers, and then draw the whiskers from the maximum and minimum to your box then. So we're going to go ahead and use our 12 pieces of data that we had for cookie stacking. So I do have them listed out in order from least to greatest for you. So we have 11, 12, 13, 14, 14, 15, 15, 16, 20, 20, 21, and 28. So what we'll do first is we'll go ahead and we'll start at the ends and we'll figure out, so there's working our way towards our median. And it looks like we do have 2 numbers in the middle. So our median value is actually going to be the average of those 2. Since they're both 15, the average is 15. So we will keep that special 15, since that's a separate one. It'll actually kind of bump out. And then we have our lower half of our data set and our upper half of our data set. So from here, we'll go ahead and we'll figure out. So we have beginning, end, begin, end, beginning. So now we're in between a 13 and a 14. When I add those together, I get 27, and dividing by 2, that's going to give me a 13.5. That's my lower quartile. Same thing is going to happen up here. I'm going to work my way towards the middle, and it looks like it's right here. Since the numbers are both 20, that upper quartile is going to be the number 20 then. So the last piece I have is my lower extreme and my upper extreme, and those are my 5 numbers that I have here. Off to the side, I'll often just mark quartile 1, median, and Q3. Q1 is 13.5, my median was 15, and my upper quartile was 20. So what you do is you just go to your box and whisker plot, and we plot all these 5 points just with little dots. Here's my 11, I'm going to come just a little bit above. 13.5, a little bit above. 15, 20, and 28. And what I'm going to do is I'm going to take these 3 middle pieces and I'm going to turn them into a box, which is not very great, and I apologize. So there's our box, and then we're going to put a line through that median, and then we'll go ahead and connect the whiskers to the end using lines then. So that's our box and whisker plot. Hopefully yours is a little neater than mine writing with this tablet thing. But there you go. That's our box and whisker plot with our data. So a little bit of information on box and whisker plots here. A shorter box and whisker plot is going to mean that your data is bunched together and has what we call less variability. It really just means variability, how different they are. So in this case, the smaller your box and whisker plot, the more similar your data are. They're going to be scrunched closer together on a number line. A longer box and whisker plot would mean that your data is spread out and has more variability. One of the numbers that we can look at for box and whisker plots are what we call the interquartile range. It's the range of the box. So basically, you'll be taking your lower extreme and your upper extreme and doing a subtraction problem with them. Or not extremes, lower quartile and upper quartile. So for us, those numbers were 13.5 and 20. So to get our interquartile range, which we often just call our IQR, we would be doing 20 minus 13.5, and that's going to give us an interquartile range of 6.5 then for our data set. Moving on over to page number 7, we're going to create a display that has multiple box and whisker plots on it using our data. So I'm going to share with you again, class 2's data was a little bit updated from before, so I'm going to have you jot this down. And I did put it in order right away, so it makes our life a little bit easier. We have 2 19s, 2 21s, 2 22s, a 26, and then also a 28. And class 3's data, we have a 21, a 21, a 22, a 23, a 23, a 25, a 25, a 26, and also a 27. So I'm going to go ahead and start looking for my median here. So working my way towards the center. What did I do here? 19, 21, 21, 22. Oops, I missed a data point here. I'm sorry. I'm like looking at this and it didn't match up. We did have another 22 in here, excuse me, a 26 and a 28. So then working my way towards the center, I am right here in between 21 and 22. So off to the side, I'm just going to make myself note of these 3 data pieces. So my median is going to be between 21 and 22. So that's actually going to be 21.5. And then working my way, I have 4 data points. It'll be between a 19 and a 21. So add those together, you get 40 divided by 2 is 20 for your quartile 1. And then over here, I'm going to be in between the 22 and the 26. So when I add those up, I get 48 divided by 2 is a 24. And then I have my lower extreme and my upper extreme. And we'll go through the process for class 3, and then we'll put these all on a chart together. So I'm going to look at quartile 1, my median, and quartile 3. So working my way towards the middle here, looks like I actually do have a median, and it's 23. So this piece is kind of like sacred now. It becomes like, you're not allowed to use it in your data sets. So if I look at the top 4, I'm going to be in between 25 and 26. So that's going to be a 25.5. And down here at the bottom between 21 and 22. So that's going to be a 21.5 then. So we can go ahead and put these all on here. For our class, just to kind of remind you here, our low extreme here was an 11 for us. And I put little lines on your page very lightly so you could see these. Our quartile 1 was a 13.5. And our median was a 15. Our Q3 was a 20, and then our max was actually a 28, so all the way up here. And this will hopefully be a little bit easier for us. So if I just connect these with lines, and drop that, and then I'm going to go ahead and connect my whiskers to the end. And then I'm going to go through and do the same thing for all the other charts as well. So for class 2, lower extreme was a 19, so that's all the way up here. My quartile 1 was a 20, my median was 21.5, and quartile 3 was 24, and my upper extreme in class 2 was over at a 28. So we have those. I'll go ahead and, connect those with the box. Again, mine's not beautiful here, but it'll work for our purposes. Hopefully yours is a little bit neater on your paper. So that takes care of class 2. And the final one I need to do is class 3 here. Let's see if I can select this. There we go. All right, and then for class 3, I have my lower extreme is 21. And my quartile 1 is 21.5. It's going to be like, don't know what is going on here. Here we go, 21.5. Median is over at 23. It's every time I write now, this disappears. So then 25.5. And my upper extreme here is going to be 27. So that's right here. And I'm going to go ahead and connect these with a box. Just makes it very difficult here to try to look. All right, so then there's our box and whisker plots for classes 1, 2, and 3 for our class and then the 2 others. So a couple follow-up questions here. If we look at which class tends to have a higher overall heights based on the plot, you can actually see this pretty easily on a number line because we're shifted further to the right. So this is going to be class 3. Which class has the smallest interquartile range? So this is going to be one where we're going to actually take a look at it. If you remember, our interquartile range was actually at 6.5. So if I look at these two, quartile 3 minus quartile 1, that's going to be a range of 4 for my IQR. And down here, the IQR is going to be 25.5 minus 21.5, which is also a 4. Both of those are lower, so it looks like the smallest interquartile range, this is actually a tie for 2 and 3. Largest interquartile range is my class. And which class has less variability in its stacking heights, and how do you know? So remember what we said on the previous page, that the smaller the box and whisker plot is, the more scrunched together the data is, the less variability, versus more open the box and whisker plot, how longer it is, that would be more variability then. So if we're looking for less variability, we're looking for the smallest box and whisker plot. And if you look at that one, that's going to actually go to class number 3. And it has a smaller box and whisker plot. So that's that. One last final piece of information. Since a box and whisker plot divides the data into 4 equal parts, each quartile on the plot represents 25% of the set of data. So coming back here, I'm going to grab the highlighting tool real quickly. If we were to talk about our class, we would actually have 25% of our data falls between this 13.5 up to this 15 mark that's up here then. If you look at the actual box part then, since that's actually 2 sections, that box actually encompasses about 50% of the data. If we were to go from the bottom of the box all the way up to the top, we would be looking at 75% of our data because we have 3 of those different sections then. So we're able to just kind of analyze and talk a little bit more about our data using that 25% mark then.